Every conversation about artificial intelligence begins with the same picture: a processor, a rack of accelerators humming in a data center, burning through electricity and money. But a processor is only as fast as the data you can feed it, and feeding it is a harder problem than most people realize. This is a story about the part of the machine nobody photographs. A stack of memory chips, bonded vertically, a fraction of a millimeter thick, and the Korean company that currently makes more of them than anyone else. The question is not whether artificial intelligence needs memory. It does. The question is whether SK hynix can turn a lead in a difficult technology into earnings that survive the next turn of the cycle. This is analysis, not advice, and every number here carries a date. Inside an AI accelerator, the calculation itself is rarely the limit. The limit is movement. Weights and activations have to travel from memory into the processor, billions of times a second, and every journey costs time and power. Engineers call this the memory wall. Conventional memory sits off to one side of the board, connected by a relatively narrow path. The processor finishes its work and waits. HBM high-bandwidth memory was designed to take that wall down. Instead of placing memory beside the processor, you stack it, several dies high, and connect it through a very wide interface, immediately next to the compute die. The effect is easy to describe and difficult to build. More lanes, shorter distances, far more data per second for every watt. That is how a memory company ended up at the center of an accelerator story. SK hynix does not design the most famous chip in artificial intelligence. It builds the layer that decides how much of that chip you actually get to use. It would be easy to assume this is ordinary memory, only faster. It is not. To build an HBM stack, you thin silicon wafers until they flex, drive thousands of vertical channels through them, through silicon vias known as TSVs, and bond the layers into a single block, aligned to within microns. Then the real problems start. Heat has nowhere to escape from the middle of a stack. The layers expand at different rates and the assembly can warp. One failed connection anywhere costs the entire unit. SK hynix built its position around that manufacturing problem rather than around specifications. Its packaging process, MR-MUF, floods a molded underfill material between the stacked dies in a single step. The company reports that this improves heat dissipation and controls warpage better than the alternative method. For the HBM4 generation, the base die at the bottom of the stack becomes a genuine logic chip, and SK hynix is building it with TSMC. That partnership is a signal in itself. Memory and logic manufacturing are converging, and the companies that can work across both have an advantage. In June 2026, the company announced samples of 12-layer HBM4E, up to 16 gigabits per second per pin, 48 gigabytes in a stack, and a 17% reduction in thermal resistance against the previous generation. Those are company-reported figures. Reported is not the same as proven at volume, and the distinction matters. Difficult manufacturing, when it works, shows up in the accounts, and SK hynix's accounts have been extraordinary. For the 2025 financial year, the company reported revenue of 97.1 trillion Korean won and operating profit of 47.2 trillion. In the first quarter of 2026, revenue reached 52.6 trillion won. Operating profit reached 37.6 trillion, an operating margin of 72%. The company credited demand for high-value products, HBM, high-capacity server modules, and enterprise solid-state drives. 72% is an unusual number for a manufacturer of anything. It is what operating leverage looks like when price and product mix move in the same direction at once. The costs are largely fixed. When the price per bit rises, most of that increase falls straight through to profit. But leverage is symmetrical. The arithmetic that produced those margins on the way up works just as efficiently on the way down. So how much of this market does that represent? Here it is worth being precise. In its filing, SK hynix cites an IDC estimate of 56.4% of global HBM revenue in the first quarter of 2026. That is leadership. It is not a monopoly, and the difference is not pedantry. It tells you roughly how much of this market is already contested. The rest of this dashboard is a mixture. Some of it is reported results, some is third-party estimate, some is pure scenario. Hyperscaler capital spending forecasts are scenarios. Forward price-to-earnings multiples are estimates built on consensus expectations. Price targets are opinions with a number attached to them. A low forward multiple can mean the market has mispriced a business. It can equally mean the market expects those earnings to fall and is pricing the profits it thinks are coming rather than the ones just reported. For a cyclical company at a peak margin, that second reading deserves at least equal weight. No lead this profitable goes unchallenged. Micron is the closest listed comparison. Its HBM ramp has improved, and its United States listing gives it a different investor base and easier access to capital. Samsung is the larger threat, because Samsung's constraint has been qualification and yield, not capability. It has memory, logic, and packaging under one roof, and enormous capacity behind them. If Samsung solves its yield problem on a leading-edge HBM product, the gap narrows quickly, and customers gain a second credible source. That is exactly what the buyers of these components want. No hyperscaler wants a single supplier for a part that governs its entire build schedule. Qualifying a second and a third vendor is not some distant risk to SK hynix. It is the stated procurement strategy of every major customer today. So set the optimistic case against 4 specific pressures. First, cyclicality. Memory has never permanently escaped its cycle. Record profits attract capital, capital builds capacity, and capacity eventually meets demand. Second, supply. In July 2026, SK hynix announced a 100 trillion won investment program for the Chengdu region, including a new NAND fabrication plant and an advanced packaging facility. That is a commitment to future growth, and at the same time, part of the industry-wide capacity that could normalize pricing. Third, concentration. A large share of HBM demand traces back to a small number of accelerator customers. Their roadmaps, their order timing, and their supplier decisions propagate straight into this business. Fourth, everything outside the company's control. The Korean won, export controls, trade policy, and the volatility that comes with a Korean listing. None of these makes the thesis wrong, all of them make it conditional. So is SK hynix the better artificial intelligence stock? It depends entirely on which question you are asking. If the question is which company occupies the physical bottleneck behind AI accelerators, the answer is straightforward. SK hynix has the HBM share, the manufacturing record, an HBM4 roadmap, and a partnership with the most important foundry in the world. Those are real assets, and they are difficult to replicate quickly. If the question is whether that makes the shares a safe purchase, the answer is no, and no amount of technological respect changes it. The price already reflects a great deal of good news. Testing it means asking what these earnings look like normalized across a full cycle, rather than annualized from the best quarter in the company's history. The honest version of the thesis is conditional, and it fits into a single sentence. SK hynix has a lead in the HBM cycle. The investment question is whether that lead converts into durable cash flow before new capacity and new competitors arrive to normalize it. That is the story behind the stock. It is also the risk inside the story. This video is education, not investment advice. Every figure carries the date on which it was reported. Check the current filings and market data before you make any decision of your own.